Man lifting a weight. A man receives the potential energy that he receives from the food that he intakes, and is stored in the form of chemical potential energy. Potential energy is required to lift the heavy load is equal to the weight of the load due to the force of gravity acting downward, and the height at which the weight has to be raised and can be represented as work done is equal to the potential energy released. Water stored in the dam. As the volume of the water stored in a dam rises, and the point of elevation of the water level in the dam goes high, the potential energy of the volume increases. Until the water is stored in the dam, it keeps on adding the gravitational potential energy until the volume of the water reserved in between a sturdy construction is stable, and when released, the potential energy of the water is converted into kinetic energy and water flows from the dam. Ocean currents. The ocean current generates enough energy, which is also used to run a turbine to generate electricity. The potential energy present in the ocean current is due to the gravitational potential energy as well as the tidal energy. As the density of water is less than the plates floating on the asthenosphere, hence the gravitational pull effects exerted on the Earth by the Moon is seen on the oceanic water developing tides. More the quantity of water, more will be the effect observed. A car parked on the top of the hill. Consider a car parked on the top of the hill on a steeper road as shown in the diagram above. The force due to gravity is acting slightly backward, that would result a car toss-sweep down the hill. Plus the frictional force on being in contact with the metallic road, and the air resistance drags the car backward. But still, the car does not sweep down is only because of the potential energy that keeps the car in a steady position. The free fall of a ball. When you throw the ball high up in the air, it raises high due to the potential energy applied to a ball in a particular direction being changed to the kinetic energy, and hence the ball accelerates in the air. As the height of the ball above the ground increases, the kinetic energy of the ball is converted into potential energy. When enough potential energy is stored into a ball, means when all the kinetic energy of the ball is converted to the potential energy, the ball is held stable in the air for a few milliseconds and then returned towards the ground due to the gravitational pull, and is called the free fall of the ball. But due to the free fall of the ball, it still has potential energy associated with it, and hence it bounces back after bouncing the ground, converting its potential energy to kinetic energy. Slinky walking down the stairs. If you have a slinky, place it on the step of your staircase and drag another end of the slinky to one step down and leave it. You will observe that the slinky will walk down the stairs by itself without applying any external force to it. This is because, for the coils of the slinky to collapse from one end to another, the potential energy stored is converted into kinetic energy. The kinetic energy is then converted into potential energy and supplies enough potential to the slinky to raise its topmost end and step onto the next. This is how the slinky is able to walk down the steps independently. On reaching the plain ground, the slinky comes to a rest at the equilibrium position, distributing equal energies on both the ends, and the balance is created. While walking down the stairs, the force due to the gravity was also acting on the slinky that made the coil collapse together one above the other, and there was no chance for the mass or the energies to balance out and attain the equilibrium state. Stretched rubber band. The rubber is an example of an elastic material that regains its original shape and size after being stretched. When a rubber band is stretched, the potential energy is inbuilt in the rubber band, which is equal to half times the elastic constant and the square of the change in length of the rubber band on stretching, and is called the elastic potential energy due to elasticity of the rubber. This elastic potential energy is converted into kinetic energy when the rubber band is released. This energy is so high that it will thump on your finger if you released it in your hand or swerve away with the energy. Archer's bow with string pulled back. The archer attaches the bow and pulls the string back. On pulling the string back, it built enough potential energy in the string. When the string is released, the potential energy is supplied to the bow, which is then converted into kinetic energy to direct the bow towards the target. A rock sitting at the edge of a cliff. A rock sitting at the edge of a cliff would have rolled down the cliff if there was no potential energy stored in the rock. Hence, a rock sitting on a cliff possesses potential energy. If the rock slides from the cliff and falls due to the external pressure or air resistance, then this potential energy is converted into kinetic energy used in the acceleration of the rock. Nuclear fission. A nucleus splitting into two in a spontaneous nuclear reaction is called the nuclear fission. This energy released during the fission reaction is tremendous. The potential energy stored inside the nuclear is converted into kinetic energy, hence after splitting into two nuclei, both the nuclei divert from each other, attaining very high speed. Football on the ground. Football at rest has zero kinetic energy with it. On kicking the football, the potential energy is supplied to the football. The ball is displaced from its initial position by converting this potential energy into kinetic energy. Tree branches high up on the tree. Have you wondered how the branches of trees remain amalgamated together even at high heights, then attracting down the ground due to gravitational force and falling off from the trunk of the tree? This is mainly because of the potential energy stored in the tree. Food. The food that we eat has chemical potential energy that provides energy after metabolism. This potential energy is stored in our body and is utilized while doing any activity. Batteries used in a remote control car. The batteries that are used in remote control cars possess chemical potential energy, which is supplied to the car to accelerate. The chemical energy stored in the batteries is released in the form of heat and light through a chemical reaction. The gravitational potential energy of the Earth. The gravitational pull of the Earth is exerted on all the objects surrounding it and present on its surface. The energy acquired by the Earth to exert a force due to gravity is known as the gravitational potential energy of the Earth. The potential energy associated with the object above the ground at height, h, is given by the formula, where g is the acceleration due to gravity. Electric potential energy. Electric potential energy is a potential energy stored by the charged particles and corresponding to the conservation of the Coulomb forces acting between the two charged particles separated by the distance, r, and is formulated as potential energy. Firecrackers. Firecrackers are made from chemical powders that are highly reactive and fissionable. When the firecrackers are lit, the chemical potential energy is released and hence becomes explosive. Mass pulled attached to the string. Consider a mass attached to the one end of the string and another end of the string is fixed on the wooden plank attached tightly to the wall. When the mass is displaced to a distance, x, from its initial position, the potential energy is set into the string is equal to the half times the spring constant and the square of the displacement given by Hooke's law states that the force required to either extend or compress the string is directly proportional to the displacement within the limit of the elasticity of the spring and represented as where K is a spring constant. When the wooden block is released, the block on the table slightly moves ahead from its initial position because of the elastic potential energy in the spring. The potential energy is converted to the kinetic energy, and finally, the block of mass returns to its initial position. Trampoline. While jumping on the trampoline, Newton's third law acts, which states that every action has an equal and opposite reaction. The force exerted in the trampoline on making a jump over it will react back on the body, exerting a force equal in magnitude and opposing the direction of force pushing the body in vertical direction from the trampoline. This is due to the elastic potential energy of the trampoline. On jumping, the potential energy is supplied to the body, which is then converted into kinetic energy utilized for the next jump on the trampoline. The body is held in the air for a few milliseconds because it exerts enough potential energy. Due to gravitational force, the force of the body acts downward and the body returns back to the trampoline, and the process repeats each time, increasing the potential associated with the body and hence experiences free fall while returning down on the trampoline. Athletic running. For running for a long distance, the athlete needs enough potential energy. The potential energy is effective while running, which is a form of a kinetic energy. If a person doesn't have enough potential energy, then the person will fall down on the ground. The intake of food provides us with the required energy, which is stored in the form of chemicals inside our body. Ferrous wheel. As the wheel rotates from the ground to the topmost point on the wheel, the potential energy is stored in the body, and hence the passenger feels heavier by weight. After reaching the top of the wheel, the potential energy is converted into kinetic energy, and the body freely accelerated downward due to the effect of gravity, hence the passenger feels lighter till reaching at the bottom of the wheel. Frequently asked questions. What is the gravitation potential energy of a ball having a mass of 280 grams when it is raised to a height of 5 m above the ground? Given, mass of the ball m equals 0.28 kilograms. Height h equals 5 m. Acceleration due to gravity g equals 9.8 ms²2. Therefore, potential energy. What are the different types of potential energies you can classify? The potential energy is internal energy stored in the system. The 5 main classifications of the potential energies are the gravitational, electrical, nuclear, chemical, and elasticity. What are the various factors affecting the potential energy? The energy is always conserved, while it can be transformed from one form of energy to another. The factors affecting the potential energy are the mass of the object, its accelerations due to gravity, height from the source, the external sources applied, mobility of the particles, etc. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.